tried these first. If you haven't, I really highly suggest trying them, then pause the video, or watch the video, pause, try the next one, and go through that way. All right, so the first one is a log equation, and obviously we have to, we can't solve a log equation. See how you have log plus log? You can't have two logs on the same side of the equation, so we need to condense these logs right here. We're going to make it log base x, and then because it's addition, we're going to multiply. 4 times 2x plus 5, that's going to be 8x plus 20. Equals 2. And then, of course, log form. Now, if we have log on both sides of the equation, you could just drop that log. But without the log on the other side, you don't have a log with the 2. See? It's not log of 2. It's log of x, log base x of 8x plus 20 equals 2. You have to convert this to exponential form. So I take my base, which is x. This is my exponent. Remember, log equals exponent. Log is an exponent, so x to the second, that 2 right there, equals the amount 8x plus 20, whatever that is. So x raised to the second power equals 8x plus 20. Now, take a look at what you have. You have an equation now without log, but it's got x squared in it, so that's a quadratic. We get it equal to 0. So bring those over. You get x squared minus 8x minus 20 equals 0. So it's x minus 10, x plus 2 if you factor it. And that's going to be 10 and negative 2. All right, so 10 and negative 2, of course, is a choice. However, you need to check. You plug the negative 2 in for the base, you get a base negative 2. You can't have a negative base for a log. So we have to reject that negative 2, and the answer is just the set containing 10. So be sure to check. Which is a solution set of this equation here. Again, log on the same side. This time it's subtraction. So this is going to be log base 4. Let me change colors. This is going to be log base 4. And it's going to be x squared minus 65 over x equals 3. Similar situation. I have a base and I have an exponent. Base is 4. My exponent now is 3, so 4 to the third equals the amount, x squared minus 65 over x. And now I have an equation to solve. Okay, 4 to the third is 64. So I'm just going to erase that just to save room here. And I'm just going to make that 4 to the third a 64. Make sure you write that out on your paper there. So that's going to be a 64 because it was 4 to the third. And then I need a common denominator, so I need x. My x's drop out. I have a quadratic equation that I want to get equal to 0, right? So I'm going to have x squared minus my 64x over minus 65 equals 0. And then I need to factor that. X minus 65, x plus 1. And then 65 and negative 1 would be the x values, but you can't have negative 1 because then you'd have a negative in the log, which you cannot have. So negative 1 is a reject, and you just get 65. All right? So I'm just going to erase for more room here. All right, so the next one is a condensed log that I need to expand out. It's just saying which is equivalent to. So, but you can tell all the choices are expanded. It doesn't say expand, oh, it does say expanded form, but all the choices are expanded, so they don't even have to say expanded form. You could tell what they want done. So each of these needs its own log. Now remember, x squared is going to be the 2 log x, so it's not going to be that guy. It's got to be one of these 3. All right. The cubic root of y is 1/3 log y. That's going to be 1/3 log y. So it's not going to be that guy. See that cubic root there? That's going to be the 1/3 log y. So we eliminate that. And then division, so subtraction. And then everything under that division is going to have to be after the subtraction in parentheses. So it had to be this guy right here. All right? Because this one doesn't have the parentheses that you need. And again, everything under that division it gets subtracted. So it's minus log 5 minus 4 log z. That's got to get distributed out. This guy here, remember what this means. This means inverse. They didn't say inverse, but you need to know that that means inverse. So I have y equals log base 3 of x plus 5. That's a 3. My inverse, I'll switch colors. My inverse will be x equals log base 3 of y plus 5. Now I'm kind of stuck because that y is in the log. But if I use exponential form, you should know that logs and exponents are inverses of each other. So when I have a log, the inverse will be exponential. So immediately, I know if I'm doing an inverse and I have a log, see how I started with a log and I want the inverse? I know the answer is not D because D is a log. The inverse of a log is not going to be a log. The inverse of a log is going to be an exponential, so it has to be one of these three here. So let's do it the right way. The base is 3. The exponent is x. 3 to the x equals y plus 5. And then subtract my 5 over. So I get y equals 3 raised to the x power minus, that's a minus 5. Okay, 3 raised to the x minus 5. And that is choice B. Of course, they put the f inverse back in there, which we talked about. All right, this guy here, which correctly identifies the domain and range. You would put this in your calculator, and then you could see the domain and range that way. But if you just understand what the shifting does, so my regular 2 to the x, my parent function would be y equals 2 to the x, right? That's my parent function for the base 2. So my parent function is going to do this. All right, where the asymptote is 0. It's getting closer and closer and closer to 0. It hits 0, 1, so on and so forth. Remember what these things mean, right? This right here, this 3, means 3 units to the left. So this moves 3 units to the left, and then 4 units down. 4 units down. So if I go 3 to the left and 4 down, I'll change colors. If I go take this point 0, 1 here, and I go 3 units left and 4 down, I'm at negative 3, and my asymptote was 0, but I went 4 units down, so now my asymptote is now at negative 4. Y equals negative 4. My asymptote is now y equals negative 4. It was 0, now it's negative 4 because I shifted down 4. So that affects my range. My range, because now I'm going to do this, right? Up like that, something like that. I'm sketching, okay? So now it goes from negative 4 to infinity. This went 0 to infinity. My parent function goes 0 to infinity. This goes negative 4 to infinity. All right, so that's going to be the range, and that's either choice, so it's not A, it's not C. And then my domain is always negative infinity to infinity. For all exponentials, it's always negative infinity to infinity. It is going forever to the left and forever to the right. Okay, so that is going to be choice B here. And then the end behavior. This is testing end behavior. I know my log function. So I know my regular log function is going to hit 1, 0. We should know that by now. Here my parent log function does that. But with a 2-unit shift to the left, that's a 2 left shift. Okay, everything goes 2 to the left. So it's going to go here, right? And so the asymptote was, the vertical asymptote was 0. Now it's going to be 2 to the left. So now this is 1, 2. My asymptote is now going to be at 2, negative 2 rather. X equals negative 2. Negative 2 is my vertical asymptote. So my log function is going to do something like that. Okay? I'm just estimating. So, what is my end behavior? Well, as x approaches infinity, y approaches infinity. Okay, that's easy. As x approaches infinity, y approaches infinity. So that's going to be, it's not this guy. As x approaches, that one's right, and that one's right. So all of these 3 could be right. Now, What happens as x approaches negative 2? Because x doesn't go to negative infinity, it only goes to negative 2. So as x approaches negative 2, here it is, as x approaches negative 2, y approaches negative infinity. Y approaches negative infinity. All right, so there we go, and it is choice C. All right, moving along. Which choice most accurately describes the transformation needed to get from graph of the parent function to this graph right here? Again, just knowing the shift, this is a 2-unit left. This is 2 units left right here. And this guy is up and down. It's plus 5, so it goes 5 up. So 2 left, 5 up. 2 left, 5 up. That's choice B. All right. Condensing now. On part 1 we had expanding. Now we're condensing to a single log. Single log means I write log one time. Okay? And then I'll go parentheses. Now I see a subtraction. So I know that's going to mean there's going to be some kind of division. This is a fraction bar that I'm messing up here. All right? Don't be so messy. There's stuff above it and stuff below it. Whatever comes before the subtraction, that's going to be above it, and I'm writing on it, and this is all going to be below it. All right, so here we go. 3 log x, that's x to the third, and then half log y is the square root of y. Again, this is just review. You should already know this. Just refreshing your memory, hopefully. And then, of course, 1/3 applies to both of these, so it's going to apply to the a and the b. All right, so that's going to be the cubic root. The cubic root, I need a 3 there, a little 3 there. And then a and times b squared. Remember, 2 log b condenses to b squared, log of b squared. All right? Solve each equality equations, be sure to check. All right, so now we have log on both sides. Still need to condense the one side. I can only have a log on each side one time. I need to condense these. So I'm going to make this log base 2 of 6 times this 3 goes to the x cubed, right? So it's 6x cubed equals log base 2 of 48. All right, so I have log base 2 of 6x cubed. That 3 is the exponent of x, and equals log base 2 of 48. Because I have log base 2 on both sides, I will drop my log base 2, and I have 6x to the third. I can't write my 3's with this pen. Equals 48. Divide by 6. That's a 3 still. Equals 8. And then x cubed equals 8, so I take the cubic root of both sides. The cubic root of 8 is 2. So you would have 2 for x. All right? And over here, just switch colors. How about purple? Log base 3 of 12 equals, now I have to condense this, log of subtraction, so I know it's division. 2 log t is t squared. Oh, I forgot base 3. Base 3, that just stays there. And then over 3t. Okay, over 3t there. Now I have log base 3 on both sides. 12 equals t to the third over 3t. I need a common denominator. That's going to be 3t. All right, so those cancel out. I have t to the third. Or is that? Oh, why is it t to the third? That's a square. That's a 2. T squared, sorry. T squared, and then, so it's t squared, and that's 36t. So t squared minus 36t equals 0. And that's going to be t times t minus 36 if I factor it. It's not different to perfect squares. So you might have been thinking t plus 6, t minus 6. It's not. It's a common factor of t that gets pulled out. T comes out, you left with t minus 36. All right, so t equals 0. That's a t equals 0, and that's a t equals 36. And of course, you can't have a 0 in the log, so that cannot be 0. So t equals 36 is my solution there. So I'm just going to put that in braces. You should have 36. All right, how about these where you need to solve with an exponential equation? See how the x is in the exponent? That's going to require logarithms to solve that. Let's subtract the 17 first. I know it's been a while since we did these. 20 to the x equals, subtract 17, you get 53. Now, I can't find a common base between 20 and 53, so I'm going to need log. Log base 20 of 53 equals x. Now, there is a way to type that in your calculator with the log base function in the math menu. Or, what you do is this. You can go log, using common logs, you can go log of 53 divided by log of 20. And that's the change of base formula. And that comes out to be 1.3. So x equals log 1.3 when you divide those logs. Similar here, divide out the 7 first. You end up getting 4 raised to the x plus 1 power. See that variable up in the exponent? 161 divided by 7 is 23. Again, 4 and 23, not going to get a common base. I need logs. So I'm going to change colors here just so we don't get confused. So it's going to be log base 4 of 23 equals x plus 1. Again, calculator, log of 23 equals, divided by log of 4, and that equals x plus 1. And then subtract 1. So it's this thing, and then minus 1 after. So you get x equals, you get actually 1.3 again. If you don't have a calculator with you, that's what you end up getting. I'm going to just kind of branch that off there. Okay. All right, so log of 16 over log of 27, we have to write that in terms of 2, 3, and 4, factors of 2, 3, and 4, because that's the only thing that's given to us. So I'm going to write this as the log of 4 squared, or 4 times 4, 4 squared, over 3 to the third power. Because 3 to the third is 27, and 4 squared is 16. Now I can expand this out. 2 log 4, 2 log of 4, minus 3 log of 3. Remember that exponent comes down in front of the log. 2 log of 4 is c, so it's going to be 2c minus 3, and then log of 3 is b. So 2c minus 3b, just making the substitution there. And focus and directrix. All right, so vertex form, we did this in lesson 30. That would be a review. We're trying to throw some review on here so we can get ready for that final exam coming up in only 5 short months. But anyways, we don't want to lose track of things we've done before. The vertex here, you negate that, keep that the same. So the vertex, remember, will be -1, -3. -1, -3. Can't write my 3's with this. So that -1, -3. All right, so right here, right? There's my vertex. My focus, because it's a positive A, right? My focus will be above it, and my directrix will be below it. Well, you need P. P is 1 over 4A. So it's 4 times 1/8, which is 2. If P is 2, that means we go from the vertex, we go up 2 and down 2, and that gives us the focus and directrix. Up 2, remember this was at -3, so we're going up 2 units. Right there is our focus, and then down 2 units is going to be our directrix line. So that's our directrix, and here's our focus, and our parabola must do something like this. Okay, so here's my focus point, and that occurs at -1, -1. So my focus is -1, -1, and my directrix is y equals what? Well, it was -3, and then I went down 2 units, so that's going to be -5. Y equals -5 would be my directrix, and my focus would be -1, -1. All right. Page 3. Here's another review problem. We've done a lot of these though. So they give us a polynomial. They give us p of negative 2 is 0. That's telling you that it's a 0. Negative 2 is a 0, so it's a solution. You can use negative 2 to break this down to a smaller polynomial. So this is going to be 1. 1 times negative 2 is negative 2. Add down 0. 0. Add down 9. And you get negative 18. And remember, you have to get a 0 here. If you don't get a 0, it's not a 0. You did something wrong. They're telling you it's a 0, so you have to get a 0 at the end. Now, what's left? Well, this is x squared. This is x. And this is just plain old 9. So x squared plus 9 is left. X squared plus 9 equals 0. How do I solve that? I'm going to have... Well, we did learn how to factor this, actually. This can be factored. If you remember, it can be factored x plus 3i, x minus 3i. Otherwise, you have to subtract 9 from both sides and take the square root. So doing it that way, it's x squared equals negative 9. Take the square root, take the square root. What is the square root of negative 9? It's plus minus 3i. So you get plus minus 3i either way, because this gives you negative 3i and this gives you positive 3i. So either way, you have a solution set of 3i and negative 3i. That's the remaining roots. So Matt is trying to decide which investment option is better for him. $15,000 for 12 years at 2 3/4 interest, or $15,000 at 2.6% interest compounded monthly. The first one's compounded quarterly. That's the difference, and of course the rate is different as well. Same amount of money being invested. All right. So what we have is our this formula here, and we've done a bunch of these, right? So I'm just going to fill this out for you. Make sure you did it right. Give myself a break from talking, right? The rate, 0.0275 divided by 4, because it's compounded quarterly, and that gets raised to the 4 times 12, because it's 12 years and it's 4 times per year. So 4 times 12. I'm just going to give you the answer here. This comes out to be $20,840.97. And then option 2 is same kind of setup, but it's 0.026. And now we're dividing by 12 because it's monthly, and that's raised to the 12 times 12. 12 times per year, 12 years. So times 12 times 12. Calculator work, being careful in the calculator, gives us $20,485.40. So clearly option 1 would be the better choice, because they'd have more money at the end of that time, at the end of the 12 years. So option 1, and you would just explain that it gives him more money. Interest. So we want to find interest earned and future value of an annuity with this information. Okay, so future value is AF. That's what we're finding. And then you can find the interest earned after you get the future value. All right, so R is the recurring payment. That's $600. And then we're just following the formula. 1 plus I. Now I can be done on the side. I is going to be the rate, 0.035, divided by the total number of payments per year, per time period, so per year. See how it's compounded quarterly? All right, so that's going to be divided by 4. 0.035 divided by 4 comes out to be, I is 0.00875. So again, I is the percentage divided by the payments per year. 0.00875. Okay, raised to the n, so that's going to be 60, because there's 60 payments. Where did I get 60 from? Well, n is going to be 15 years and then 4 payments per year. 15 times 4 is going to be 60. So n is 60 and I is 0.00875. Okay, then minus 1, just following the formula, and then divide by 0.00875. Just putting this into your calculator carefully. You may want to do the top, and then hit enter, divide by the bottom, enter, and then times 600. That's going to be your best bet to make sure mistakes aren't made. If you type it all in together, you got to have parentheses all over the place. You need parentheses here, you got to have parentheses on the top, and then you got to have parentheses for the whole thing. All right, it ends up being $47,081.35. $47,081.35. That is the future value. AF is the future value. Now, what's the interest earned? Well, the interest earned is going to be the amount you put in taken away from that. Because don't forget, you're putting in 600 every quarter. So 600, 600, you're adding 600, adding 600. That's your own money that you're putting in. All right, now the rest of the money is the interest. So what is 600 times how many payments? Well, we said 60 payments. 600 times 60 is 36,000. See? So of this 47,000, 36,000 was put in by the person, whoever put the money in, 600 a month. Say it's you, right? You put in 600 a month. So this amount is your money, but it turned into 47,000, right? So the difference between those is going to be the amount of interest you earned. So we're going to subtract those, 47,081.35 minus 36,000. And that is going to tell us the amount of interest we actually earned, $11,081.35. So that's going to be the interest earned. Okay, the interest earned is going to be $11,081.35. The excess money on top of what you put in. All right, number 16, a colony has 4 bacteria in it. Sorry about the loss of video here. You'll get it back for number 17. Grows by 28% each hour. That is important. We're going to write an exponential function that models the situation, but we're going to make sure that our K is in hours. K is in hours. All right. So I'm just going to get a little thinner pen here real quick. So assuming exponential growth, so we're going to use our exponential growth formula, which again is given to you on the reference sheet. I'll write it on the board or give you a reference sheet in class tomorrow for the quiz. So A equals A0. Now A0 is what you start with, so it's going to be 4 E to the KT, basically. KT, because we don't have a T0. T is time, and then 0.28 is going to be our K. So it's 0.28 T. All right, so 4 times e to the 0.28 T. We've done this before. How many bacteria will there be after 1 full day? Now, don't plug in a 1 for T, because remember, we are in hours here. 1 full day is 24 hours. So you need to plug in 24 for T. So it's going to be 4 e to the 0.28 times 24. Okay, 0.28 times 24. And then just put that in your calculator. I did this ahead of time for you just to save you time. It's 3,315 to the nearest. I just did it to the nearest bacteria. Bacteria. All right. And then C to the nearest tenth of an hour. How long will it take for the population to reach at least 2,000 bacteria? So we're going to say that's the amount we want to get to. So 2,000 equals, start out with 4 e to the 0.28 T. Divide by 4. I feel like we've done a lot of these, right? So 500, sorry. 500 equals e to the 0.28 T. All right, and then take the natural log of both. So it's going to be natural log ln 500 equals 0.28t. By now we know the shortcut to get rid of that e. You just take the natural log, all right, and then divide by the 0.28. And so this in my calculator comes out to be approximately 22.2, rounded to the nearest tenth, 22.2 hours. 22.2 hours is when it reaches 2,000 bacteria. All right. Newton's law of cooling. Okay, so we've done a bunch of these. The temperature that we're getting the pizza to become is 475. That's my T. All right, do color coded here. The ambient temperature is that room temperature, 74. So we're going to put 74 there. 74 again. So it's plus parentheses minus parentheses e to the negative blank t. Oh, well, it'd be time would be 2 minutes. See, 2 minutes. Okay, so t is going to be green, 2, and then k. And my initial temperature was that when it came out of the oven, 600. All right, so that's going to be blue. 600 is my initial temperature. All right, so there we go. Subtract the 74. That gives us, let me solve this in black. That gives us 401 equals, and 600 minus 74, of course, is 526. E to the negative 2k. And then divide by 526. Remember, leave this. Leave that instead of getting some long decimal. That equals e to the negative 2k. So we do natural log of that thing equals negative 2k, because it's base e here, which natural log base e, that's what natural log means. So we do that, and then we divide by negative 2. K equals, and it comes out to be 0.136. 0.136. Most of us were getting pretty good at these. And how long does it take the pan to get to 225 Fahrenheit? So that's the new temperature. We want it to equal 225. Same formula. Same situation. So it's 526 e to the net. Now it's negative 0.136 t. We don't know how long now. Okay? So we're going to subtract 74. So we're going to get 151 equals 526 e to the negative 0.136 t. Divide out 526. So once again, natural log, because it's base e, natural log of 151 over 526 equals negative 0.136 t. Okay? And then divide by negative 0.136. That gets my t by itself. Divide by negative 0.136. T equals 9.2 minutes. All right, so when you plug that guy in your calculator, you should get 9, and divide by negative 0.136, you should get 9.2 minutes. Anybody else have writer's cramp? Ouch, my hand hurts. All right, so hope you got something out of this. Rewatch it or rewatch certain problems if you need to, and I'll see you for the quiz tomorrow.